so today we are moving into section 5.2. That's okay. So 5.2, this section is proving trig identities. So the easiest way for me to say this today is the fact when we're proving trig identities, you are going to manipulate or change the left side of the equation until matches the right side. So we never change the right side of the equation. We keep manipulating the left until we can get the right to match. Okay? So we're actually going to start off, and again, there's no two that are exactly the same. So it's not like I can do this is just like these and this is just like that, because everyone's going to be a little bit different. But I want to start off by showing you we can do it algebraically without the trig stuff first, before we start throwing in sine, cosine, tangent, cotangent, all that wonderful stuff. Okay? So here is example number 1. I would like you to prove, bless you, the algebraic identity. And let's start off with kind of an easy one. If I have x squared minus 4 over x minus 2 minus x squared minus 9 over x plus 3, I want to show that this equals 5. So I'm doing any kind of manipulation on the left-hand side I can to change this, work it, whatever. So what do you notice about the two tops of both of those fractions? Perfect. They are both the difference of squares. So this is actually x plus 2 times x minus 2 over x minus 2 minus this one is x plus 3 times x minus 3 over x plus 3. And again, it still equals 5. So what we're trying to do is to change this side to match 5. In the first fraction, we can cancel the x minus 2's, right? And the second one, we can cancel the x plus 3's. So right now, I have x plus 2 minus x minus 3, and we're still trying to show that that equals 5. So now what should I do next to get rid of the parentheses? Distribute. All right, so I have x plus 2 minus x plus 3. Then if I collect like terms, my x's drop out, right? And 2 plus 3 is 5, and that equals 5. So we're done. So you have to keep manipulating the left until it meets the right. So far. Okay? Any question on the idea behind this?
So what does x equal?
We're not trying to find x at all. We're not solving for x. That does not matter at all.
So it's just solving equation.
You're not solving anything.
You're proving that it's right.
You're proving that the left side actually equals the right side.
Yeah.
It always will. There's only a few problems today where they want to know if something equals sine, when we'll get to that. But all right, so let's try another one with algebra. Yes.
If it's wrong, would it just be no solution?
It's not going to be wrong. It's not going to be.
If it's wrong, we did it wrong.
Correct.
Okay.
Okay, so here we go. Let's do another one with algebra. So you guys can tell me what you want to do. So let's try this. Example number 2. Let's go with x to the third minus x squared over x minus x minus 1 times x plus 1. And I want to show that this equals 1 minus x. All right, somebody give me an instinct. What do you think we can do to simplify this at all? Get out the x and multiply those? I agree. So on this top one, we can undistribute how much? An x? Just 2. Yeah, well, careful. Can you still take out another x then? We can take out x squared out of both of them, right? That leaves me with x minus 1 over x minus. Let's multiply these two together. Now that's the difference of squares, and we get x squared minus 1. That's the difference of squares. Do those match yet? Nope, so we got to keep going. Now, what do you notice in the first fraction we can do? Yeah, we can cancel one of the x's, right? So I can get rid of this x on the bottom with one of them here. Okay? So now I have x times x minus 1 minus x squared, whoops, I'm going to distribute plus 1. Does this equal x minus 1? Or sorry, 1 minus x, my bad. Still doesn't, okay? So what else can we do? Distribute, okay? So x times x is x squared. X times negative 1 is negative x. So minus x squared plus 1.
Cross out the x squared.
Okay? So I have negative x plus 1. Does that equal 1 minus x?
Yes.
It does. I agree. So, I mean, you can write it in the other form, but this does equal the same as what this is. Yes?
Is this what we're doing today, or are we doing this but with like a bunch of sines and cosines?
Correct. With a bunch of sines and cosines. So you have 2 problems in your homework that are algebraic like this. The rest, back to trig life. All right? So we're good with this. We understand what we're going to do today? All right. So let's go to example number 3. Example number 3. All right. So this is what actually starts at number 11. So this is number 11 through your 16 today. It's going to be something along this line. It just says in the directions, prove the identity, which means you need to manipulate the left to match the right. So let's go with how about if I have cosine squared x minus 1 over cosine x, and I want to show that it equals negative tangent x sine x. Yes?
You cross out the x, or the cosine x on the bottom to cancel with the cosine squared x.
No, because it's subtracting with 1. You can't. Huh? It is, but it's not going to help you at all. You're correct, it is. What else do you see? No? It isn't. So remember that when we talk about your Pythagorean identity you have on your thing, right? That is sine squared plus cosine squared equals 1, right? So if I were to subtract cosine squared to the other side, it's 1 minus cosine squared, not what's up there, right? It's not the same thing, okay? So in this one, when you only have one word or a monomial on the bottom, let's say, when you have a monomial on the bottom, you can distribute that monomial to both pieces. So it's like taking something that you're making a common denominator for and adding them together. We're just going to separate it out, all right? So in this one, I can rewrite this as the cosine squared x over cosine x minus 1 over cosine x. Do those equal each other yet? They do not, so we have to keep going. What do you notice about the first term? What can I do? Now we can cancel the cosine that's on the bottom with the one on the top, right? Okay, so here I have cosine x minus 1 over cosine x. Okay, what else can we do? Oh. Okay, that's secant. How does that help us?
Make 1 over cosine x that equals sine.
No. Good try. Well, we just took it out of the common denominator, didn't we? All right, so let's try this. Since this way is not clicking, you guys started it the other way. Let's do this. I'm going to backtrack, draw a line across. We're going to try it a little bit different for you. Because this way is not clicking for you guys, so I want to try something different. And I need to make my eraser a lot smaller. There we go. All right, so we're going to go back to our starting spot. And you guys mentioned the Pythagorean identity to begin with, right? That's the first thing Brooke and Noah, you both mentioned, right? So let's look at that for a second. We said that sine squared equals 1 minus cosine squared, correct? Okay, so if I have sine squared equals 1 minus cosine squared, how can I change that? What can I do to that to match what I have up there? Multiply everything by a what? A negative, absolutely. If I multiply everything by a negative, I get negative sine squared x, negative 1 plus cosine squared x. Excuse me. Now we can change the top into what? Yeah. So let's change the top line into negative sine squared x over cosine x. Does this match what we have on the right yet? No. We do now have a negative, though. We see that the negative is there. So I'm going to rewrite this sine squared as negative sine x times sine x. That's the top, right? Everybody agrees that's top? On the bottom, I have cosine x. Still doesn't exactly match where we want to go.
Oh, but sine x over cosine x equals something.
Yes, what is this? This is negative tangent x, and we have our sine x already there. Do these now match? So now we're done. Yeah. It would have had a couple more steps, but yeah. You guys went to this first, so I'm going to go to that first. Let's try another one, okay? I want to follow whatever your instincts are. That's what we're going to do, okay? All right, so let's go to example number 4. Same idea. In this one, I want you to prove cosine x times tangent x plus sine x cotangent x. I want to prove that this equals, I need to get that out of my way, that this equals sine x plus cotangent squared x. Or no, cosine squared x, excuse me. Sorry, that's supposed to say cosine squared x. My bad. All right. So first thing we should probably do, since the right-hand side doesn't have any parentheses, probably should get rid of those first, right? So we're going to distribute to do that. So we're going to go cosine times tangent. So I have cosine x tangent x plus cosine x times sine x cotangent x. Do those match yet? Nope, not yet. So now, you'll notice on the right-hand side, those are all in sine and cosines, right? So what do you think we should do?
Take out the tangent and the cotangent.
Yeah, let's get rid of those because we know it doesn't help us, right? So we're going to change this first one. This is cosine x times. Tangent is sine x over cosine x. Plus, this is cosine x, sine x, cosine x over sine x. Still doesn't exactly match. Yeah, so in the first set, what reduces? Cosine x's. So I have sine x. Plus, what reduces here? The sine x's. So I have cosine times cosine. What is that? Is that where we wanted to go? It is. Yeah. You just gotta, the easiest way to look at it is whatever you don't have on the right, like if you don't have any cotangents or tangents, get rid of them. If you have something that's negative, figure out a way to get there. All right? Let's do one more of these, and then I want to talk about the other little section, and then I'm done. Okay? So example number 5. One more proof. Let's do let's do one like this. Let's say I have 1 minus cosine x times 1 plus cosine x all over cosine squared x. And I want to show that this somehow magically equals tangent squared x. All right, what do you guys see? The difference with squares, absolutely. So if I were multiplying 1 minus cosine times 1 plus cosine, what do I get? You're close. What if I were to write it out this way? And I'm going to put it, because it's 1 minus c and 1 plus c, right? If I were to multiply these together, 1 times 1 is 1. We get negative c, positive c. Negative c times c is negative c squared. Right? So this top actually multiplies to 1 minus cosine squared x over cosine squared x. Does that match tangent squared yet? No. Yeah, so let's change the top. Noah suggested we change this into sine squared x over cosine squared x. Does that match yet? Yeah. Sine squared over cosine squared is tangent squared. And that's what we're looking for. All right, so that one wasn't too bad either, right? These first ones today aren't going to be bad. Now, there is one small section, which is 5 through 10, that I want to talk about. So example number 6, this is your 5 through 10. It just wants to know, does the expression equal sine? So maybe I give you, how about this? Tangent x over secant x. I want to know if that equals sine. So it's kind of like a proof. You set it equal to sine. You just got to change this side until we get it to match, right? If you never get it to match, you actually get to say no today on just those. And I think you have one of them that you're going to be doing that says no. So what can I do here? Yes, let's change this into sine x over cosine x. And since we don't have any secants over here, let's change this into 1 over cosine x. Yes, very good, Leah. So we have a fraction divided by a fraction, which means we get to multiply by the reciprocal. So I have sine x over cosine x times by cosine x over 1. What do we see we get to do?
Cross out the cosine.
Yeah, so does this equal sine? So then you just say yes. Okay? So you have a couple problems where you're doing algebraically today. You have a few problems where you're just deciding if it equals sine, and then you're going to prove a few for me. All right? And I'm